Hey kids, Miss Kulkarni here. Let's continue with kinetics and reaction equilibrium. So for any reaction rate, there are some factors which are essential. They will increase or decrease the rate of the reactions. Which are those? Let's talk about some of those factors. One of them is the type of the reaction. And we will talk in a minute about different types of reactions and how and why the type is going to affect the rate. Next thing is temperature, and temperature can stir up things. We'll talk about that. Then pressure. This is only for gases, not for solids or liquids. Then it's surface area, and this is strictly for solids. Then for some reactions, there is a catalyst which can make some changes. And of course, the concentration of reactants. What is the molarity for the reactants? That's also important. So let's talk one by one each of those. First thing, the type of reaction. As you all remember, there are four major types of reactions: synthesis, decomposition, single replacement, and double replacement. Now I'm going to make a statement and I'm going to explain why I'm making the statement just in a minute. The type of reaction is definitely going to find out to what extent reaction will proceed or what is the rate of reaction. Double replacement reaction is the one which will generally go extremely fast. And why is that? If you look carefully, there is no change into the ionic charge or the oxidation number from reactants to product side. So, since there is no change in charge or oxidation number, it is much easier process. Whereas any of the other reactions, synthesis, decomposition, or single replacement, they all are much slower because they all have to go through the change in the charge. So what do we call those reactions? We call them as redox reaction. So if you remember, the first three reactions are generally redox, and this is not a redox reaction in general. So what is a redox reaction? A redox reaction has two words, red and ox. Red stands for reduction and ox stands for oxidation. And if you remember, reduction is gain of electrons and oxidation is loss of electrons. You can remember Leo the lion says grr, or you can remember oil rig. So it is oxidation is loss of electrons, reduction is gain of electrons. And then this is easy for us to remember each of the process. So let's take an example. In the synthesis of iron sulfide, from iron and sulfur, what is happening? There is oxidation and reduction both happening. Let's find out what is the situation. This is iron and sulfur reacting with iron 2 sulfide, that means it's Fe is +2 and sulfur is -2, so FeS is the formula for iron sulfide. Let's write down the oxidation numbers for each of the substance on the top. Iron is the element itself, so it will be 0 as the charge. Sulfur again is the element itself, it's a neutral atom, so 0 is the charge. FeS is an ionic compound, so this is +2 and sulfur is -2. So what do we get? We end up having iron going from 0 to +2 and sulfur is going from 0 to -2. If the charge goes up, okay, like this, 0 going to +2, that is oxidation, and the charge gets reduced or it goes down, then that will be reduction. So in a way, we figured out iron is the one which gets oxidized and sulfur is the one which is getting reduced. Let's take some more examples and find out which reactions are redox and which one are not. The very first reaction, magnesium is 0, bromine is 0, and what do we get here? +2 and -1. So you can easily figure out magnesium is going from 0 to +2 and bromine from 0 to -1. We have both of those changing their oxidation state, so that is a redox reaction. Let's take the second example. In this one, sodium is +1 because it's an ionic compound. Sodium here also is +1, so nothing happened. Let's take hydrogen. It's +1 here, and again here it's +1. So nothing much happening. That means it is not a redox reaction. How about the third reaction? Zinc is 0, hydrogen is +1. Let's go to the right side. On the product side, we have hydrogen 0 and zinc is in an ionic compound, so it is +2. So zinc changes from 0 to +2 and hydrogen from 1 to 0. Since there are two elements changing the oxidation states, it is a redox reaction. How about the last one? And each one is an ionic compound. So lead is +2 here, potassium is +1. Again over here, those are ionic compounds and it's +2 for lead and +1 for potassium. Nothing happened. Lead was +2, that remained +2. Potassium remains same too. So it is not a redox reaction. Now, let's take one step back. What is the type of first reaction? It is two elements reacting together to form a compound. So it is synthesis. And synthesis was a redox reaction. Second one is two compounds reacting and forming two different products. So that is a double replacement reaction, and that is not a redox. Look at the third one. That was single replacement and it is a redox. Fourth one is double replacement and that is not a redox. So how do we find out if a reaction is redox or not? If we know the reaction is double replacement reaction, we can easily say that that will not be a redox reaction. And if it is any of the other types, it will be most probably a redox reaction. Let's talk about the next factor, which is temperature. A temperature increases the frequency, the number of times per second for collisions. It also increases the effectiveness of collision. So how does it help us? It stirs up the particles, creates more moment, so that means more collisions, and that results into more energy. And if there is more energy, it is easy to reach the activation energy which is required for a reaction to take place. So simple, increase in temperature will be increasing the rate of reactions, of course, most of the time. We will talk more about that later, how it can affect different types of reactions differently. Okay, let's move on to our next factor, and that is pressure. This is only valid for gases. So what happens when pressure is increased? If you remember, according to Boyle's law, P1V1 is equal to P2V2. So pressure and volume are proportional inversely. So if we increase pressure, volume goes down. In a small volume, if you have same number of particles staying together, obviously they're going to have more collisions. And if they get more collisions, what has happened? Reaction goes faster. So we can easily say increase in pressure, that means it's increasing in reaction rate. But keep in mind, it's only for gases. Here is the next one, surface area. In general, if you grind the particles for solid, that will be increasing the surface area. Smaller pieces will have more surface area. And how does it help reaction? It will give rise to more collisions. So increase in surface area will have more collisions, and more collisions means more energy. That means the reaction rate will increase. Okay, there is one more important thing to keep in mind, and that is catalyst. A catalyst may or may not be available for every reaction, but if it is available, it magically increases the reaction rate. And what does it do? There are different concepts. One of the important concepts is it lowers the energy for activation. So you may not need as much energy as you needed without a catalyst if we have a tiny bit of catalyst. There is also one more theory. It may come up with a different pathway altogether. Okay? What is a catalyst? A catalyst is something which is not at all consumed in a reaction. In fact, we can obtain the catalyst back at the end. So, how do we write down a reaction with catalyst? If A and B are reacting to form AB, we write catalyst X on the top of that arrow. And then, what's the mechanism? Out of A and B, one reactant combines with catalyst forming a compound, and that compound reacts with B, and then we get catalyst release free. Look at the figures on the left side here. They both are for exo and endo different reactions, but the concept is exactly same. The one which is higher level, that is without catalyst, and the second one which is inside, that's the one with catalyst. Here is one more factor which affects the reaction rate, and that is concentration, or we can say molarity in case of solids. So if we have higher concentration, increasing concentration, what is more? The number of particles is more. If number of particles is more in same volume, obviously there will be more collisions. If there are more collisions, the rate will be increasing. Let's summarize what we learned in this video. The rate of reaction depends upon all these factors. Number one, type of reaction. And out of all reaction types, if you have a double replacement reaction, they often occur quickly or faster. And single replacement, they are much more slow reaction. So if the reactions are slower, they go through the ionic charge difference changes, and they are redox reactions. So in a way we know that double replacement reaction will be faster, others will be slower. Temperature goes up, rate goes up. Pressure goes up, the rate goes up. Surface area goes up, the rate goes up. Catalyst is added, rate goes up if we have a catalyst. And concentration or molarity goes up, rate goes up. So I hope you will remember all these factors which can change the rate of reaction. I hope you enjoyed the video. I will see you in next video. Bye.